We're working on the integration of engineering as well as looking at simple machines. We study the input and output forces, projectile motion, speed. Then the integration for math includes probability, the probability of landing on the target.
I've been working with the catapults. You built them. We've been working for about 2 weeks. We're going to collect more data today. And we're also starting to think about things that you can control with your catapults, right? Things that you can change for better accuracy, right? Would somebody like to share out some of the variables that they were thinking about?
The angle of launch, because the way we did it with our catapult, the angle of launch was kind of high, so the projectile was flying really high up into the sky rather than straight forward. So I think that if we changed the launch angle, it would be easier to predict where it went.
How many rubber bands you have? If you have a lot, the resistance is more, so you could have more speed of launch, and yeah, I guess that's it.
What about the speed makes that for accuracy?
Because if you want a target that's far away, you'll want more speed to launch it. If it's closer, you want less speed to launch.
You want to be looking at your catapults to see, why am I not getting perfect accuracy at the target? Is it something like with my actions, or is it something with the design of my catapult? All right, you are going to need your notebook, something to write with, and we're going to grab your catapults. Okay, that's all you need.
We're trying to measure the accuracy, so we have to get a lot of data points of how far it went and what ring it hit on the target to measure the probability that it will hit the bullseye or any other ring. It hit the bullseye once and hit the outside ring 3 times, but it hit the middle section 5 times.
I'm aiming for the target that's in the middle, kind of, with the blue outer ring and the red in the side. And it usually hits. In general, it misses a couple times and usually goes farther than the target. So I'm trying to work on using less tension versus more tension to shoot it.
Marks places where the rubber band can be put, then pulling it off. It's a more precise way of like knowing exactly where you're releasing it and having it the same every time.
So how far you pull it back.
The accuracy.
So, that was helping with the accuracy.
Wait. So what's the difference between, like you're saying this is the notch that you like, but what's the difference between this and that notch?
This actually changes like the size of the lever arm.
How will we use probability with our catapult? Determine the experimental probability from your catapult data. Is it what you expected?
We did a huge probability packet last week, but we know to determine the experimental probability for our case, it's the number of times it landed on the target over the total number of launches. Yeah, Brian.
We only got to fire it once because we had a lot of problems downstairs, so wouldn't our probability be 100% either way?
All right, yes. So for people who did not get enough data, I would like you to team up with somebody else at your table who did. Okay, so number of hits on second ring.
And so we had 7 out of 18.
All right, so you had 7 out of 18.
And then so we turned that into a decimal by dividing 7 by 18 and got 0.39. And then we turned that into a percent, which was 39%.
Nice. So we could make a sentence, right? You have 39% accuracy on your second ring.
Yeah.
It asks them to, in one location, write down how many times their crayon landed on each section, and then gives them another box right next to it to determine what the experimental probability is.
So experimental probability. So 1 out of 18, and then 2 out of 18, 7 out of 18.
The next step is to identify which variable they'd like to change in their catapult, write down what it is, and then draw a sketch on how they'd like to make that change.
We're going to put supports on the side of the structure to keep the lever from wobbling back and forth.
All right.
Does that sound okay?
That sounds good. And are you still going to try and use the weight at the bottom?
Our rubber band wasn't strong enough to shoot it far enough to the target, so we thought about putting another rubber band so it would have more resistance against when we pull it back, so then it'll go farther and hit the target.